So I'm working on an adaptation to run ER40 collets in the K&T rotary head mill. And I promise you I will get you that video of the collet nut and the retainer and everything when I'm done. I'm making 2 sets, one for myself and one for Rico out in California. But I have been using it, and I got some of the rather cheap Chinese ER40 collets that come in these little boxes, and they're great for shipping, but I don't plan on keeping them in these long term. I don't think these things are going to hold up, and they're really kind of a pain to open up once they're all covered in oil and filth. So rather than poking holes in a sheet of plywood and popping these things in that, I came up with a little bit cooler solution. So let me show you what I'm going to be doing. For the ER40 collets, I decided to make an interlocking plastic block that could be added to in the X direction and in the Y direction. So we basically have 2 male dovetails and 2 female dovetails. Took a little bit of playing around with to get the right dimensions to fit the collets with the right taper and have enough room for a indicator of the size. And these things came out to be, I think, 2 1/4 by 2 1/2 by about 1.5 inches thick. And I put some holes on the back to reduce material, and also these I could probably tap these and mount it from the back side, but it came out really nice. And basically you just change the configuration to change what the number is, and I can add configurations if I ever get metric series of collets, and just print these as I need them. Yeah, 2 1/4 by 2 1/2. And so the way these interlock, for a complete set, the ones I bought, I think I have 12 from 1/8 inch up to 1 1/8 inch, and this is how I would set them up. Now these are all 1-inch models of the collet. I couldn't find a configured model off of GrabCAD that had every size, but this is how the array of collet storage blocks would look. And I think that's pretty cool compared to a sheet of plywood with some holes drilled in it. And here are the finished printed parts. We did 2 of them. Now my son-in-law tells me that the resin for both of these is really the same material. It's just 2 different colors. And I think they came out really nice. So the collets fit in, and they actually register on the taper. The bottom is a little bit of a clearance, but they're very easy to pull in and out. The interlock feature, it can be engaged. It is exactly line to line, and I don't want to force this together. If I drove it with a hammer, it would go. But I took 1/1000 off all of the 3 male surfaces here and here, and I'm going to print up the rest of these, and then hopefully they'll be able to hold together, but still come apart without tearing things up. Really happy with the way that came out. And then the little number panels, maybe I will infill that with a black Sharpie or something, and paint the numbers white. But if I ever get metric collets added in, I can I can just print up additional ones of these, change the lettering, and then intersperse them in the collection of this array by size or however I want. While I was printing things up, I decided to print up a 1/4 scale replica of a spanner wrench that I guess you call this a crow's foot wrench. The packing nut on the Skinner steam engine is about a 2.5 inch or so hex, and it doesn't need much clearance to get over top of the actuation rod, but this will go on and enable me to snug up or loosen the packing nut, and then slip. These edges are rounded, and I would slip a piece of, I think it's 1.25 inch, 1.5 inch pipe on here to get a little bit more leverage. But that was a neat little addition. And the other item that we printed up, this is a set of rotary head trip dogs. Drawings for the rotary head trip dogs were given to me by Mark Hollenbaugh. Mark has a number of 2D rotary head mills, and he also outfitted one with a power Y-axis. So his is the only one that I'm aware of that has a power Y-axis, which is really cool. But he does not have rotary head trip dogs. So I modeled the parts in SolidWorks from the drawings, and it is a really cool part. There's a 15-inch radius on the back side to register it against the perimeter of the rotary head, and a groove, or rather let's call this a tenon, that will keep them oriented in the groove. There's two actuation ramps which will return the head operating lever back to the neutral position, and two bypass slots which will allow the opposite direction to pass underneath it without activating it. So the orientation of these inboard and outboard ramps is important in which direction they face and the location of the slots. Now, because this is a 15-inch radius, I can't make these parts 100% on the rotary head mill. I'm going to have to use the rotary table in order to swing that big an arc. And the way these work, if you wanted to mill, let's say a 90-degree arc, you would orient these at approximately 90 degrees on the perimeter of the head, and they would stop the rotation of the head at or near the points where you would not want the cutter to travel any further. These load on the scale on the rotary head. When you engage the rotary head with the lever, there's a projection on the handle that actually protrudes down kind of outside of the head of the machine. And then as these trip dogs would travel around, they're designed so that the groove would let it pass by the one, and then the ramp would actuate it on the other. Now the gray ones are actually accidentally mirrored. If you look at them compared to the tan ones, the tan ones are correct in that, I guess when the ramps are facing each other, the bottom one has the groove on the left and the top one has the groove on the right. These somehow got mirrored, so he reprinted them up, and we'll try these out. I am going to make these in steel, or actually I'm probably going to make them in stainless steel, and then but I have a feeling that the printed ones are going to hold up just fine for the amount I'm going to be using them. This is a 15-inch radius, which will nest it on that rotary scale. I can't mill this on the rotary head because I can only mill an 8-inch diameter. So I am going to have to use the rotary table and fixture these blocks of steel to mill that 15-inch radius. Well, I hope you enjoyed seeing some of the cool things I was able to do with the 3D printed parts. I mean, I'm kind of really enthused about this stuff, to the point where if my wife asks me what I want for Christmas, I think I know the answer. I'm going to tell her a DeVlieg Spiromatic jig mill and a 3D printer. So anyway, hope you enjoyed it from Engineers Workshop. I'm on the road in California. Didn't get to do any work in the shop, but I figured I'd show you these parts, and it is progress towards the goal of doing more machining. So once again, until next time, stay safe. I'm out here in not so sunny California, where my company just bought us some new high-dollar retractable safety lines. They required the steel kind, which give you up to 30 feet of movement, but if you fall, they arrest that fall. So we're going to get harnessed up and take some measurements. Waiting on them to give us access to the channel. One of the things that happens in wastewater channels is they got these big influent gates that aren't closed, very often, and then when it comes time to close them to shut off the flow, they stick. So Another hour delay while we're just waiting for them to give us authorization. So here's a properly secured device. There's no way that this can come off because it does interlock behind the bracket, and there's no way to get that off without bending something, so this is safely locked out. Notice that tab right there. Some of the other pieces of equipment don't have that interlocking tab, so that even when the device is attached and there's a lock in place, you can just remove it and operate the gate. Well, after we pointed out the inadequacy of the lockout guard yesterday, the city re-engineered a solution to this. So kind of from the whatever it takes files, we've got a chain around the primary shaft, and then a quick release cable device that secures this shaft. You can probably still pry all this off, but you'd have to work at it, and this is good enough to meet the intent of the lockout.